I'd like to thank the organisers of the conference and to Louise Marie for inviting me over to speak about management of potato cyst nematodes. I'm John Pickup. I work for Science and Advice for Scottish Agriculture, and my responsibility is regulatory control. So, thank you very much. I'm obviously taller than Vivian. And so I'm putting government legislation into practice and ensuring that the EU directive is implemented. Okay, outline of my talk today is I want to cover PCN outbreaks, looking at worldwide implications of PCN, and I'll touch a little bit on what Inga's talked about there, and the eradication programs, and if you can't eradicate, containment, and then I'll go into the European situation where we're living with PCN and that we have a statutory component in relation to preventing the transmission of PCN with seed potatoes, and then we have a more deregulated, which is left to the growers to manage the PCN situation with their ware potato production. And there I want to separate out two issues, managing yield and managing the land. Unfortunately, the short-sighted approach is to manage the yield. The longer term and the better approach is to manage land. And we're trying to encourage people to look more at the land and less at the yield. But that's an increasing problem because a lot of growers are now growing on land that they rent from their neighbours, and they're quite often more concerned with the short-term prospects because the long-term management of the land might not affect them because the person who owns the land might not rent to them the next time round. So that's an ongoing problem. Okay, potato cyst nematodes, for which I apologise, I come from Europe. PCN is the abbreviation for potato cyst nematodes in Europe. Over here it can be pale cyst nematode. So when I talk about PCN, I'm actually talking about potato cyst nematodes and not Globodera pallida. If land elsewhere in the world outside South and Central America is growing potatoes, then it's extremely unlikely to contain PCN. PCN originated in South America, in the Andes, as Vivian has pointed out, and has only really been transmitted to other parts of the world with potato cultivation. If high levels of PCN are allowed to develop, then yields are severely compromised. Previous speakers have demonstrated that. So the first element of any control strategy should be outbreak management. And for outbreak management, you need a good surveillance program, and then you need biosecurity to ensure that eradication, and you need to address the means of transmission of PCN and the various control pathways. Outbreak management. Outbreaks have been recorded from most parts of the world where potatoes are grown. The only major potato producer in the world that has yet to report an outbreak is China. And reports of PCN remain scarce from many countries, with some countries with extensive potato areas, and these are most notably Australia, India, and probably, although the information's not always available, some parts of the former USSR. But the main issue here for North America, and Inga's pointed this out, is that outbreaks of PCN in North America are very scarce. This essentially, Inga's gone through this. There's a few other recorded outbreaks that are on here. There was an outbreak in Delaware in 1968 that was reported in the journals. In Canada, there's an outbreaks in Newfoundland where I think both pallida and rostochiensis are present. Vancouver Island, 1965. Quebec in 2006, which Inga's mentioned, and there is a record from Alberta in 2007, although I don't think that has ever really been confirmed as a field outbreak. And also Mexico has PCN recorded from a number of states. The majority of those outbreaks are of rostochiensis, with pallida just present in Idaho and Newfoundland. PCN are treated as quarantine pests throughout the world due to the severity, and Inga's slide from New York State has amply demonstrated that. However, in Western Europe, PCN are widespread, and there is a view in some quarters that we shouldn't be treating PCN as a quarantine organism in Europe. And to expand on that, this is a slide extracting relevant information from the International Standards on Phytosanitary Measures, which are worldwide acceptance procedures and protocols for recognizing quarantine pests, and a lower priority, which is a regulated non-quarantine pest. And essentially how PCN are treated in North America is the quarantine pest description, and in Europe it's the regulated non-quarantine pest approach. So if we look at pest status, it does work. In North America, pest status, PCN are absent or of very limited distribution. In Europe, present and widely distributed. The procedures are in North America, are essentially to address all pathways and implement phytosanitary measures for all of those pathways. In Europe, the statutory approach is to make sure that we're just addressing PCN on potatoes for planting. So it's just seed potatoes in which PCN is regulated. Impact there's probably not that much difference. We do know so much about PCN that we would say that impact is known, certainly in Europe, and predicted. We probably know exactly what's going to happen in North America if PCN spreads around. I don't think that's a major issue. Official control, where PCN is present, we have in North America an eradication program or a containment program in place. Whereas in Europe, we're only really addressing the issue in relation to plants for planting. So there is a different way in which we treat PCN in North America and Europe. Looking at outbreaks, and if we look at characterizations of outbreaks across the world, early detection of PCN has proved exceptionally difficult. Infestations, when they've been found, have usually been well established. And by the time detection occurs, those populations are generally high and causing visible damage. Outbreaks have then, by that stage, have generally spread to neighboring and connected fields. So therefore, it's very difficult to keep the lid on PCN outbreaks. In Quebec and Vancouver Island, those outbreaks have been associated with very short rotations. I think I was once told that in Quebec, in the area in which PCN were detected, the rotation was potatoes, snow, potatoes, snow. So I think that was an additional challenge in some of the areas. But generally, eradication has been hard to achieve. Western Australia have achieved eradication of PCN. Vancouver Island, their area on the Saanich Peninsula is still out of production as far as I'm aware. Potato production in that area is prohibited, but it's been over 30, probably over 40 years without potatoes, so almost certainly that has been a successful eradication. And I think Delaware also fell into the Western Australia approach, where basically the land was, moved over to concrete production and was basically built on. So those have been ways in which PCN has been successfully controlled. So looking at soil sampling, I'm sure that I could get a much more impressive photograph of demonstrating how small a soil sample is compared to the amount of soil present in the field if I came over here and looked at some of your fields. But this was a field that was available locally, but it's still a massive amount of soil in the field, and you can only take a very small amount of soil. No matter how effective and efficient your soil testing method is, you're only ever going to be looking at a very small proportion of that field. And that makes detection of PCN after potatoes of a PCN have actually been introduced into the land very difficult. This is a figure that I quite like to use. I've adapted it from the Golden Nematode Handbook, which was written by Spears in 1968 as a guide to managing PCN in New York State. And essentially it shows population build-up years after introduction and assumes that you're on a rotation of potatoes, snow, potatoes, snow. It's every year. So in this situation, when we look at the EU sampling rate, the standard EU sampling rate, which is aimed at detecting a population of 3.8 million cysts per hectare, you've got to get up to a level here where you've got 3.8 million cysts to have a chance of detection. And if you're on constant rotations, you can do that 1 year, 2 year, 3 year, 4 year, and you're there within 4 years you can detect PCN. But generally people are not using rotations like that. And this also based on a susceptible crop being planted. Economic damage threshold comes in after another year's rotation, and visible damage threshold after another year's rotation. So by the time you're actually seeing things in the field, you've actually had 5 crops in there, and you're 6 years after the original introduction. So it's a long time before you actually see PCN. And that's the reason, really, why I think PCN is so difficult to manage. In reality, we don't grow on year-to-year rotations. So if you increase, if you say have a 3-year rotation here with the blue line, you're looking at 12 years before you've got a chance of detecting PCN. If you're looking at a 6-year rotation, which is what we have in Scotland, you're looking at 30 years after introduction before you're going to see, you're going to have a chance of detecting PCN with soil sampling, which means that I always think that we're working with a massive time lag. What I'm seeing now is the result of what decisions people made in terms of PCN management back in 1986. So it's a super tanker. If you want to stop and turn a super tanker around, you've got to have a lot of space and a lot of time. So there's a big time lag here in terms of managing PCN. PCN eradication programs, as I say, Western Australia, Vancouver Island, Delaware, passive management, containment leading to eradication, prohibition of potato production, removal of land from agricultural use. Idaho, as we've heard, much more active eradication. Soil fumigation with methyl bromide and T-lone 2, much more immediate, trying to eliminate PCN at a much more rapid rate, and achieving quite considerable success. However, I'd like to now move on to more the situation that Vivian was talking about, which is the management of PCN in Europe, and using my particular experience from Scotland. Many countries live with PCN, and it's at considerable cost. Estimate of about £50 million a year in terms of yield losses and costs of using chemicals. But there's also an additional cost in there. We have to use long rotations as well. And actually factoring in the economic costs of long rotations is quite a tricky thing to do. When our potato growers in the UK were surveyed as an industry, the biggest problem they've got is not, the biggest pest and disease problem they've got for potato production is not blight, it's not virus, it's PCN. That's what they tell us. So PCN is believed to have been introduced into Europe in the late 1880s when, as a result of potato failures due to blight epidemics across Europe, including the Irish potato famine, the potato breeders in Europe went out to South America to collect new breeding material and inadvertently introduced PCN with the material they brought back. First recorded in Europe in 1881 and then was found in the UK by the early 1900s. And basically, PCN was too widespread before we actually knew it was there and we actually had sufficient knowledge of its biology to actually implement an eradication program. So essentially, the North American situation, we're sort of 100 years ahead of you in terms of PCN. And hopefully, you can learn a lot from the mistakes that, not necessarily the mistakes that we made, but the knowledge that we didn't have at the time. So Vivian's already given a bit of information like this. This is essentially where I carry out soil tests, which is otherwise is where people grow seed potatoes, where the color is darker, there's a greater intensity, and this is where PCN occurs, rostochiensis and pallida. Essentially where we grow potatoes, we have PCN to a greater or lesser extent. There's a few areas where we haven't recorded PCN. The Orkneys, for example, up here, we are PCN free as far as we can tell, but essentially where we're growing potatoes, we have PCN to a greater or lesser extent. We have an EU directive. I was very much involved in Brussels over the 15 years it took us to negotiate this directive to get a harmonised approach to PCN management in the EU. It's applied to seed potatoes, and it thus targets the main risk of transmission of PCN from one infested field to another. All land in which seed potatoes are to be grown has to be tested for PCN. We have a harmonised sampling protocol for pre-crop PCN testing that is applied across the EU. It prohibits the production of any potatoes for planting on infested fields, and it prohibits the planting of potatoes known to be infested. It does require an annual survey of wear potato land so that we know how well we're doing. But as I say, I still think that that's got a 30-year time lag before we actually see, before we'll actually see any benefits of the new directive. It permits wear potatoes to be grown on infested land as long as they're subject to an official control program. That official control program is down to each member state of the EU. It sets out measures to minimise the risk of spread of PCN because we know we're going to be producing contaminated potatoes on infested land. And it recognises resistant varieties as integral to PCN control. It sets out a protocol for testing resistance, and as Vivian's shown you, it defines a scoring system for varietal resistance. Management of wear potatoes, as I said before, is largely down to individual growers and individual companies. And the aims there are either to protect the yield, which is generally primarily the target for the farmer, or to protect land. We've been working with a consortium in the UK to provide a new guide for PCN management, and we've spent a lot of time arguing about what thresholds should be. If we're looking to protect yield, we're generally looking at thresholds in the region of 10 eggs per mill, but that's open to quite a lot of debate. If we're looking to protect land, then basically if PCN's there, you should be looking at using resistant varieties to prevent 20 to 50-fold increases, which you will get on a susceptible variety. We have common practices use long rotations to take advantage of natural decline rates of 20 to 30% of the population per year. So long rotations in the absence of host plants are a valuable tool. For that, you need to make sure that you're managing any groundkeepers that might be left in the land as well. We have management options, nematicide, trap crops, sterilants, and biofumigants. And they are aimed at reducing PCN populations in addition to the natural decline rates. Success rates vary, but typically they're 50% to 75%, 90% in exceptional cases. Variety choice and resistant varieties makes a big difference. And if you go in with a susceptible crop after having taken the land out of production for maybe 7, 8 years, and you're going with a acceptable crop, that land is going to return very rapidly to a very poor state of health with regards to PCN. Chemical control. The EU has steadily removed a lot of our chemical controls. We've lost aldicarbon, methyl bromide. Granular nematicides available in the UK. We did have Vidate until the leak at the DuPont factory in Houston last year, which killed 4 people, meant that Vidate is no longer available, and it hasn't been available for this year, and there's question marks about whether it'll be available next year. But we have the organophosphates, nemathorin and mocap. These are applied at planting to target juveniles, leaving the cysts and migrating towards the emerging roots from the potato tuber. They can increase yield by 50% or more by effectively reducing the initial population, the PI, the initial population. But their effect on PF is less impressive. Biofumigants rely on the release of isothiocyanates, which have a biocidal effect and can manage soil-borne pests and pathogens. Their results are very variable due to a variety of factors, but if used well, they can have a similar effect to nematicides, reducing the initial population by 70 to 80%. But they do require 10 to 14 weeks of use of the land, which generally means that the crop for that year is out of option. So unless people can grow this on some environmental scheme, like a set-aside scheme that we use in the UK, they're not widely taken up at the moment. Trap crops which stimulate PCN hatch, and they need to prevent PCN multiplication. So we can use potatoes that are harvested before the cysts mature, or we can use wild Solanum species that are highly resistant, and particularly ones that are non-tuber forming, so we don't leave anything in the ground that can allow PCN to multiply. Lychee tomato has been tried, but we have major problems in getting it established in Europe, particularly in Scotland. But it has the potential to be highly effective. Question about whether Solanum species can actually cause problems in terms of the development of other potato pathogens in the land, because you are actually introducing another Solanum into the rotation. Resistant varieties are incredibly powerful. The scoring system, basically for every increase in the scoring system of 1, there is a reduction of 50% in the multiplication of PCN. So a variety that scores 2 may produce a PFPI of 50-fold, but if it's a 3, it'll be down to 25, 4, 12.5. So essentially, by the time you get a variety that's scoring 9, you've got 1% or less of the actual multiplication. That is a very, very powerful tool in terms of managing PCN. And as Vivian has pointed out, that we do have commercial varieties now with a full range of resistance available for both rostochiensis and pallida. One of the things, Basin russet is now a russet variety that's been bred by the Dutch and has full resistance to pallida. An innovator is now, I'm told, the most widely grown potato variety in the world, and that is almost certainly due to its pallida resistance. So PCN management principles, effectively soil management practices to reduce PI, and they're valuable for containing and eradicating PCN and protecting subsequent crop yield, but resistant varieties are very important in terms of managing the PCN in that land. But I think I'm running out of time, so I need to just press on. This is a figure that Vivian sort of essentially used. This is my incidence of PCN in soil tests, and this is incidence of rostochiensis. And you can see in the last 25 years, we've seen a decline from over 4% to 1% of the incidence of rostochiensis in soil samples, and that's because 2012, the seed that we were growing, 45% of the seed was fully resistant to rostochiensis, another 5% had minor resistance, and only 50% was actually no resistance to PCN. If we look at pallida, we don't have the same situation, and we can see that pallida has increased, such that the level of pallida now is similar to the level of rostochiensis in our seed land. And quickly want to touch on a trial that we carried out at Lovenest. You've heard a lot about Lovenest in 2014. We used a range of varieties. These are the scores that they had achieved in pot tests based on the population Chavonnet, which is the EU standard reference population. We also used a treatment of nemathorin at 30 grams per hectare, the standard rate, incorporated at a depth of 10 to 15 centimeters, and we used an untreated, and we repeated this over 4 reps. We used Lovenest. Lovenest, as Vivian showed in one of her slides, actually has all of the 3 types that Sebastian has demonstrated are present in Scotland. So we've got a wide range of pallida populations in there. And when we grew our susceptible varieties, Maris piper and Osprey, we saw that the initial cyst population of around 123, 130 cysts increased to 330, 260. So we saw big increases in PCN there because we were growing susceptible varieties, but where we were growing the resistant varieties, we saw decreases. Nematicide treatment, slight change, but we were still seeing increases. If we look at eggs counts, that was cyst counts, we look at egg counts, we see a 50-fold multiplication on Maris piper, a less increase on the partially resistant Osprey, but then we saw quite minor increases, very little change on these resistant varieties. If we look at the scores that were achieved in pot tests, and we look at the scores by calculating the scores on a field basis, we saw a very good agreement. Royal has perhaps been underestimated in relation to its pot test score, but essentially what we're seeing in the field with these resistant varieties is backing up what we're getting in the pot test. They're working in the field, and that's in a field, the famous one of the famous Lovenest fields with a wide range of pallida populations. Okay, to conclude, PCN should be treated as a quarantine pest in parts of the world where outbreaks are scarce, i.e. here in North America. Eradication of PCN has proved very hard to achieve, and if it's not feasible, then keep the lid on PCN. That should be the priority. Trap crops and biofumigation, soil fumigation and biosecurity are important elements of the containment program, but only varieties which have the highest level of resistance will actually contain PCN populations once you start growing potatoes on that land. Susceptible varieties should only be grown on land that's suspected to be infested under very extreme circumstances because they will dramatically increase PCN populations. If you have to live with PCN, the management options limit field-to-field transmission by only permitting seed production on land tested and found free from PCN. Trap crops biofumigation nematicide to reduce PI, but those benefits of reducing the PI will be basically eliminated if you grow a subsequent susceptible crop. Resistance to PCN is fantastic. It's either 100% or 1% increase in the population. It's got tremendous scope. But the key factor for future management of PCN is the ability to produce resistant varieties that can gain market acceptance. And apologise for overrunning. Yes, Bjorn Njeri has talked about that. I'm not sure, has he published anything on it yet? He has, yeah. I had intended to look back at that, but I think that's come out of fairly repeated use in the starch industry, I think. And obviously that's of concern and something that we do need to look at. And that's probably the one reason why you would want to put a susceptible crop into a rotation, to prevent that selection. think, yes, I mean, for export, for example, for exports of potatoes to certain countries to meet their import requirements, we actually test soil that is accompanying the tubers. We take a certain number of bags and we extract the soil and we test that. That is an additional test. There is a good argument for testing after harvest rather than testing before, because if you've grown a susceptible crop, then you're going to have more PCN there. But the big issue there for the industry is somebody's committed a lot of money into producing a commercial crop, and you're going to then say that that commercial crop can no longer be planted, and you're not going to get a lot of people growing potatoes if they're going to run that risk. And that's the problem with planting after harvest. It's got its benefits in terms of better detection, but it's really difficult to do in a commercial situation.